Okay, so let's read through the notes. Solving quadratic equations by factoring, and then we'll do some examples. To solve a quadratic equation by factoring, make sure the equation is equal to 0 and the terms are in descending order of degree. When the equation is written in factored form, it would be a times b equals 0. Using the zero product property, either a or b must equal 0. Each polynomial must be factored and each factor set equal to 0. Solve each equation to find the solutions. Some equations will contain a GCF and can be divided out. This will make smaller values to factor. So we're going to solve each by factoring. So yesterday, whenever we did this, we were doing solving by graphing, and some of those graphs you had to say between two integers, but we're not doing that today. You're going to get exact answers for everything today. Okay, so let's start with an easier problem. On number 1, x squared equals 6x. So the first thing you want to do is set your equation equal to 0. So I've got to subtract the 6x to the other side. I have x squared minus 6x equals 0. And this is a binomial. It's not a trinomial, so you're not going to have two binomials when you factor. We're going to look for a greatest common factor first. And between the two, they have an x in common. So I'm going to take an x out of both. Then set each factor equal to 0. So x equals 0, x minus 6 equals 0. Well, this one on the left, that's solved. Okay, and on the right, to solve for x, I just need to add the 6 to the other side, and I have my two values. Any questions? Okay, so let's look at...
They don't have to equal 0. You just have to basically get 1 to equal 0.
No, you don't. Doesn't matter if they equal 0 or some number. You're just isolating each x, set it equal to 0, and solve it.
Oh.
Let's do a few more. Okay, so let's look at number 7. So to start this one, I need to set it equal to 0 again. So I'm going to subtract the 42. Sometimes they'll have it already set up so it equals 0. Sometimes you'll need to move it. Okay, so this is a trinomial on this one, so you are going to wind up with two binomials when you factor it. The first thing you want to do is look through and see if there's any common factor you can take out. This one, each number, each term, you can divide by 2. So I'm going to factor a 2 out of everything. And I get x squared minus 4x minus 21. Okay, so now you have a simpler problem to look at and try to factor. Your leading coefficient is a positive 1. So what I'm going to do is look at the constant, negative 21, and think of two factors that will multiply to be negative 21, but add to be a negative 4.
3 is negative 7.
Okay, so positive 3 and a negative 7. Multiply to be negative 21, add to be a negative 4. And so the sign does really matter when you're doing this. Now since you have a leading coefficient that's 1, you can just write it as two binomials. Write your factors as two binomials. X plus 3 and x minus 7. You can just go ahead and break it up. So you'll have a 1x in each position in your binomial. So now the next part is where you set each factor equal to 0. Now this 2 does not have a variable, so I'm not going to do anything with the 2. You can just forget about that one from now on because it doesn't have a variable. You're only interested in the factors that have variables in it, like the x plus 3, I got to set that equal to 0. The x minus 7, set that one equal to 0. Okay, so my left side, I'm going to have x equals negative 3 for an answer. On the right side, x equals 7 for an answer. Any questions? Okay, let's work one that has a leading coefficient other than 1. Is everybody ready? Okay, so let's look at number 2. I'm going to go ahead and subtract the 15, so it's already set equal to 0. Okay, so looking through all the terms, I don't see a common factor I can take out. So my leading coefficient is going to stay bigger than a 1. The way I like to work these, and you guys might have your own method that you've learned in years past, and that's fine if you're comfortable with that, but if but here's a different way if you're not comfortable with the way that you do it, or if you've forgotten. The first thing is to take the leading coefficient times the constant. 2 times negative 15 is going to be negative 30. And the sign matters on your product, so be careful with that. Okay, so I'm going to think of 2 factors of negative 30 that add to be a positive 7, your middle term. So what 2 factors of negative 30 would add to be a positive 7? Yeah, positive 10 and negative 3. So now I'm going to use those 2 terms and rewrite my trinomial. I'm going to expand it using 10x and negative 3x in place of the 7x. So it'll look like this: 2x squared plus 10x minus 3x minus 15 equals 0. It doesn't matter the order that you put the 10x and the negative 3x. Either way, you're going to get the same answer in the end. Okay, so the next step is to group and factor just group your first 2 terms and group your last 2 terms together. And I'm going to factor a common factor out. So looking at your first 2 terms, they have a common factor of 2x. So I'm going to factor that out of those first 2 terms only. Okay, and then I'm going to do the same thing with my last 2 terms. Now the goal is, when I factor the common factor out of the last 2 terms, I want to have a binomial that matches this x plus 5 exactly. Okay, so I want both terms to be positive, and I want it to simplify down to x plus 5. Okay, so I'm going to have to take a negative out of both of those to make both terms positive, and they have a 3 in common, so I'm going to take out a 3 as well. So when you're doing this, you do need to have a sign, either plus or minus, and this needs to be some number, even if it's a 1. You need to have something there. Okay, so then what's left is x plus 5. So my binomials are identical. They match, which is good. That's what I want. And now I can rewrite it, consolidate the 2x and the 3 together since my binomials are the same. So I'm going to have 2x minus 3 times x plus 5. I'm not changing anything. I'm just making it so it's a shorter equation. So if you look at it, in the first equation, you got 2x times x plus 5. Okay, so you still have that here. 2x times x plus 5. And you had this negative 3 times x plus 5. Well, you still have that in the bottom one too. It's just written more concise. So now I'm ready to set each factor equal to 0. You got 2x minus 3 is a factor, and x plus 5 is a factor. Set them each equal to 0, and then solve for x. So I'm going to add 3 and then divide by 2. X is 3 over 2, and x is negative 5. And those are your 2 values. Sometimes you'll have 2, and sometimes you'll have 1. Any questions?
What if the binomials are the same? Would it be like no solution, or would you keep going?
Yeah, you can't keep going if the binomials are not the same. So you'd have to look and see if maybe you made an error somewhere, if there's some mistake somewhere. These are going to work out to where they will be the same if you're doing it right. Okay. All right, so let's try one on your own. I would like you guys to try number 6, and I'm going to do it up here. And let's see what everybody gets. One thing I'll tell you, I like to keep the squared term positive, just because it makes it easier for me to factor. So I would subtract the 5x and the 2 to make it equal to 0. Okay, so you should be getting negative 1/3 and positive 2 for your roots. Any questions? Everybody good? Okay, so let's move on to the bottom part of your notes. Write a quadratic equation in the form ax squared plus bx plus c, where a, b, and c are integers and have the following roots. So what does that mean when a, b, and c have to be integers? What kind of numbers do they have to be if they're integers?
Whole numbers.
Positive or negative whole numbers. That's right. So you can't have fractions and you can't have decimals when you're working these problems. Okay, so on number 8, it gives you the roots 3 and 4. Okay, so they gave me the roots, so I'm going to work the problem backwards to get the quadratic equation back. So if these are the two roots, that means that x equals 3 and x equals 4. So to get the factors, I'm going to subtract the 3 to the left side, so it's equal to 0. Subtract the 4 to the left side, so that one's equal to 0. Okay, so x minus 3 and x minus 4 are factors for those roots. So to get your polynomial back, we're going to multiply those two together using FOIL. You guys remember FOIL? Okay, so we're going to multiply the first terms together, multiply the outer terms, multiply the inner terms, and multiply the last terms. And then you need to simplify it. So we'll get x squared minus 7x plus 12 equals 0. And that's your quadratic. Any questions? So let's do one that's a little bit harder. Let's look at number 11. Your roots for number 11 are 1/3 and negative 2/5. Okay, so before we start this, let me tell you something about this negative 2/5. You could write negative 2/5 with the negative in the numerator, the negative in the denominator, or the negative just out in front of your fraction. That all means the same thing. As long as you have one negative, it makes the whole fraction negative. For our purposes, for this problem, I'm going to keep the negative in the numerator. It'll make it easier in the end, okay? So the first thing you want to do is, set each one equal to x because those are both roots. Okay, and I need to have integers in the end, so the way that we're going to get rid of this is this first equation, x equals 1/3. I'm going to multiply both sides by the 3, and that'll get rid of my, whoops, that'll get rid of my fraction. Okay, same thing on the other fraction. I'm going to multiply both sides by whatever the denominator is. In this case, it's a 5. So I have 5x equals negative 2. So the reason I'm keeping the negative in the numerator is to keep this x part positive. Okay, so 3x equals 1. So I want to subtract the 1, set it equal to 0. I have a factor. On 5x equals negative 2, I'm going to add the 2, set it equal to 0, so 5x plus 2 is a factor. And to get our polynomial back, we're just going to multiply those two together using FOIL. So I'm going to have 15x squared plus 6x minus 5x minus 2. And when you combine your like terms, 15x squared plus x minus 2 equals 0 is your quadratic equation.